Ultimately, every organization, every business is going to have some kind of database. Now, a database could be as simple as a phone book or your contact list in your phone, but more likely it's going to be a software-based database that is a repository that stores all the data in some sort of structured manner. The database itself is the storage device, and it maintains and organizes the data in a way that you can then access it. If we look at this little diagram here, we can see that a user can query a database, something we call an ad hoc query, or an application can go and fetch data out of the database. Like, for example, I can have a web application that is checking inventories or prices or availabilities or something like that from a database for a customer who wants to buy something. Let's take a look at the different kinds of databases. There are a number of them, but there's really only one these days that we'll generally be thinking about. Now, there were several different kinds of database structures. In the older days, the early mainframes of the DBMSs, or database management systems, we had a concept called a hierarchical database. And this was basically where the records were in a tree-like fashion, where you had parents and then children and then grandchildren. We'll see a diagram in just a moment. There's also something called the network database model. And with the network model, you didn't have to have a strict hierarchical structure. You could have many-to-many relations. And with the network model, we could see the whole sort of structure laid out in sort of a graph, and you'd have relations in arcs. The one we most see these days is something called a relational database management system, or an RDBMS. And relational database is the data is organized into tables, and the tables are related to each other because the data has the tables have these fields, these columns, that describe attributes of the data. And tables will have fields in common. We're going to take a look at an example of that also in a moment. So here is a simple diagram of a hierarchical database model. And just so that you have sort of a sense of context, we're talking about, pavement improvement. And under pavement improvement, we have three sort of child sets of records: reconstruction, maintenance, rehabilitation. And then they further break out. So you've got like a root with children, and they break out more and more. So under maintenance, we can have routine, corrective, preventive. It's very strict and hierarchical, and it's one to many underneath it, and then one to many underneath that. Here is the same sort of concept, but in a network database model. Again, we have the maintenance here, and we have rigid pavement and flexible pavement. And it looks like it's in a tree, but you'll notice that one set of records can have multiple parents. So you can have a set of records that have multiple parents and multiple children. It doesn't have to be strictly hierarchical. It can be many to many, not just one to many. Here's an example of a relational database. In this case, I have three little tables, and they are related. In a relational database, we represent each type of thing in its own table. So down here I've got a customer table, then I have a product table, and then I have an order table. And in the customer table, I am not going to list any of their orders or any outstanding balances or anything like that. It's just customer information. In the product table, I'm not going to list any orders on the products or anything like that. It's just the products themselves and information about the products. Then the orders table has a relationship with both. Most tables have something called a primary key, which is usually the very first column, the very first attribute, and it is some way of describing each record uniquely. Employee ID, product ID, order number, social security number. Sometimes it can be a compound of several columns together, like first and last name is the primary key, but usually it's some kind of numeric value. It doesn't have to be, but it's a unique identifier so that we don't get them mixed up. And then when you have tables that are related to each other, the table that has the relationship will have that same primary key of the other tables, but it's called a foreign key, and that's what ties the tables together. So like, for example, here, in the product table, I've got item numbers, like A125 is an M18X laptop for $2,300. And then B45 is a D15 laptop for $800. In the customer table, I've got 3 customers, each with their own customer ID. So here's Susan with a customer ID of 0234, Kusala is 5, and Noe is 6. The order table, I have orders, yes, and each order is individual, like order 1001, 1002. But notice the next columns here, I have an item number, which is a foreign key to the primary key off the product table. So order number 1001 is for product A125. So here's the primary key of products, here's the primary key of orders, but this item number is a foreign key to the products. So these are how the tables are related. The next field here is a foreign key to customers. So I've got the customer numbers. So I can see that Susan, who's customer 0234, has ordered in order number 1001 an item number A125. And this is the whole premise behind relational databases. We keep the separate entities separate so that it just makes sure that the data is clean and not redundant anywhere. And then if we need to get information from several tables, we can structure our query accordingly. And of course, we'll have tables that are related to other tables. In this way, with these relationships, you can't delete a customer while they still have an outstanding order. You can't maybe delete a product while it we still owe a vendor for it. So that's the whole concept behind the relational database model. When we're creating a database, there are a lot of administrative tasks. And one of the first things, of course, is that you need to stand up a server that can support the throughput that database needs. Most database management systems will take all the resources they can. They'll take all of the RAM, they'll take all the CPU. So you got to stand up a physical server or allocate a virtual machine. Then you got to install the database system. Then you got to design the databases themselves, which means you have to actually understand what it is we're tracking. We're tracking employees, departments, managers, job descriptions, something like that, and we create tables for all of them. Or we're tracking products, customers, orders, vendors, and what's the relationship between them. And some of these can get very, very complex with lots of key relationships. Once we design it and we create the tables, we create the key relationships, then we'll put some constraints on what kind of data can go in. Like if this is a zip code field, no letters, unless it is in another country where they use letters in zip codes. Or if this is a dollar amount field, no letters, unless it is for some other reason. But usually if it's numeric, it's just numbers. If this is a name, we generally don't put numbers in there. And if this is a state code, like California, Arizona, whatever, it can only be 2 letters. So you put in constraints so people cannot accidentally or purposefully put in the wrong kinds of information. And we can also set up some indexes so we can search the tables quicker. We can set up procedures so we can find stuff quicker. So we have to design it, we have to create it, we have to put it on a server, we have to maintain it. Databases require constant maintenance. You're constantly re-indexing because the data is changing constantly. So you're constantly defragmenting the database, you're constantly tuning it up, you're re-indexing the tables, you're setting security so that only people who are supposed to get in that table can. Maybe you're creating views so that some people in HR can see all of the employee information. Other people can only see some of it, like they can't see the salary or other designations or social security numbers or private information like that. So you'll, as an IS auditor, you need to look at specifically, are they maintaining the database and how well did they plan and implement the security and how well are they updating the security? Because I tell you, it is so frequent that people come and go out of job roles and then you've left them in as a system administrator or as a database administrator or someone who has the ability to change the structure of a table. You got to stay on top of all of that, which is why it's better to put people in groups and give the group the right, and then you take people in and out of the group. Here is an example of a relational database management console, but I'd like to actually show you one live.